In this video, we're going to practice power rule. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. The idea of power rule is that we're multiplying two functions together and we want to find the derivative. Now our first instinct would tell us, well, just multiply the derivative of each one and there you go. Unfortunately, power rule doesn't work that way. The way power rule works is that for this function right here, we're going to first take the derivative of the first factor, but we're going to leave the second factor alone. Then we're going to add to that this function multiplied by this derivative. So let's write out what this would look like. So we're using y notation, so our derivative is going to be dy dx equals, so first we want to find the derivative of 4x minus x squared. So that's going to be 4 minus 2x. Now we're going to leave this one alone. This is how power rule works. You just take the derivative of one of the factors. So we leave it as 4 plus 5x. Now onto that we're going to add a second part. That second part leaves this one alone, 4x minus x squared, multiplied by the derivative of this one, which would be 0 plus 5. Now to simplify this, we'll expand this out. So when we expand these two, we have 16 minus 8x plus 20x minus 10x squared. Now we'll simplify this. Now we don't need to FOIL this because, well, anything times 0 is still going to be 0. So we just have to multiply these two factors by 5. So we have 20x minus 5x squared. And when we combine like terms, we have negative 10x squared and negative 5x squared. So we have negative 15x squared. Then we have 20x and 20x is 40x minus 8x is 32x. And then their only constant term is 16. And so this is the answer that power rule would give us. Now someone would look at this problem and say, well, why don't you just multiply them together in the first place? And you'd be right. You would definitely be right. Let me show you what that would look like, because you would get the same answer. If we multiply these together, we're going to have 16x plus 20x squared minus 4x squared minus 5x to the third. Now we can simplify this by combining the two like terms in the middle. We have 16x squared minus 16x to the third, or sorry, 16x squared, that's 16x minus 5x cubed. So now when we take the derivatives here, we have dy dx, 16x, not x squared, is going to be just 16. Negative 16x squared, according to power rule, we bring down the 2, so that's minus 32. Actually, that should be a plus. So that should be plus 32x. And then finally, same power rule here, minus 15x squared. So you do get the same thing. And so the obvious question is, why do power rule at all? Well, power rule is useful for all types of functions. People will want to avoid power rule when you have polynomials because power rule works with polynomials pretty well. But let's look at this second one. Here, power rule is much better for a problem like this because, well, this is a product. Well, how is it a product? Well, let's rewrite this. Instead of e to the 2x, we'll write it as e to the x quantity squared. Well, to square something simply means that you're multiplying it, that function, or that quantity, by itself. So here, f of x equals e to the x times e to the x. So it is a power rule type problem. So to find the derivative, we take f prime of x. First, we take the derivative of e to the x, which is e to the x. And the second one we leave alone, e to the x. And then we take e to the x, the first one, left alone, times the derivative of the second one, which is also e to the x. Now here we're multiplying these two together, which as we showed over here is the same thing as e to the 2x. So we have 2e to the 2x. And there's really no other way you could do this right now other than with product rule. Now later on we'll learn another rule called chain rule that will make this work a little bit easier, but this can be done using product rule. So let's look at the next one. Here with the next one we have two functions. We have x and then we have sine of x. Two different functions. One isn't a polynomial. One could be a monomial. So power rule would work for x, but not for sine of x. So to find f prime here, we first have to take the derivative of x, which is 1, and then we leave sine alone. Then we leave x alone and take the derivative of sine, which is cosine of x. When we multiply these together, we have sine of x plus x cosine of x. Now these have nothing in common, which means we can't simplify this any further than that. This is what f prime of x, the derivative, will equal. Now looking here at number 4, this one, we have two functions. We have 9x squared, and then we have f of x. Now f of x we don't know, but we do know what its derivative is. Its derivative is just f prime. So anytime we want to say what the derivative of f is, we're just going to put f prime in its place and not worry about what is f of x. We don't know what it is. We just put f prime. But since we're multiplying, this is a power rule problem. So g prime of x is going to equal, we take the derivative of 9x squared, which is 18x, multiplied by f of x, we leave that alone for now, plus 9x squared, we leave that first one alone, times the derivative of the second, f prime of x. Now to simplify this, we'll see, well, what can we factor out of both of these? Well, we can factor out a 9, and we can factor out an x. And so inside, what we're left with is a 2 from this quantity times f of x plus an x in this quantity times f prime of x. Now the next one features, this one has one quantity that is being squared, and this is similar to the second example where you had e to the 2x, or e to the x quantity squared. So we could think of this as 1 minus 4a to the 6th times 1 minus 4a to the 6th. Now this happens to be a polynomial, which means we can actually simplify this first before we do that. Now I'm going to show you what that would look like, but I'll also show you what power rule looks like, since that is what we're doing. So over here, we're going to write f of a equals, and we're going to expand this out. So it's going to be 1 minus 4a to the 6th minus 4a to the 6th plus 16a to the 12th. And if we combine the like terms, we have 1 minus 8, a to the 6th, plus 16a to the 12th. Very straightforward polynomial, which means its derivative, f prime of a, well, one's going to disappear. Negative 8a to the 6th, that's going to be negative 48a to the 5th, plus 16 times 12, that's going to be 192a to the 11th. So that's what our derivative ought to look like. Now let's see if power rule can get us there any faster. So power rule says that we take the derivative of the first one, which is also going to be the derivative of the second one. The 1 disappears. Negative 4a to the 6th is going to become negative 24a to the 5th times 1 minus 4a to the 6th plus. Now what will happen is these two factors will trade places. The first one will be left alone, 1 minus 4a to the 6th times negative 24a to the 5th. Now we're adding two quantities that are identical. So it's going to be 2 times these two quantities, negative 24a to the 5th times 1 minus 4a to the 6th. So first let me multiply in the 2. So we have negative 48a to the 5th times 1 minus 4a to the 6th. And now, if we multiply in negative 48a to the 5th into this quantity, we get negative 48a to the 5th plus 192a to the 11th. And so there we go. They match. Now, did this take less time than that? No, probably not. Looks like it took more work than that. But some people do prefer to see the power rule worked out. So let's look at the next one. Now the next one features sine. Again, sine is not a polynomial, but it is being squared, which means that we can write this as sine of x times sine of x. So we can use power rule, dy dx, since we're using x and y notation. So dy dx is our derivative. The derivative of sine is cosine times sine of x plus, then we leave the first factor alone, sine of x times cosine of x. Now we have two factors that are identical, similar to what we saw up here in number 5, where these were identical. So we can simplify in the same way. We can just say this is 2 times sine of x times cosine of x. And we really don't need the parentheses at this point. We can just write 2 sine of x cosine of x. And if you remember your trig identities, you remember that this simplifies to just sine of quantity 2x. So you can actually make that answer a little bit simpler. Let's look at the next one. Now here we've got two different terms that are added together. One has power rule, the other one doesn't. So here we're multiplying these two. Here the 2 is just a coefficient. And as I always say, coefficients, they just cling. They hang on for the ride. So first we'll take care of the product rule right here. So the derivative of 2x is 2 times sine of x. Then we add to that 2x. We leave that alone. Now the derivative of sine x is cosine of x. And then the derivative of 2 cosine x is negative 2 sine x. Now let's expand this out because this one will simplify. We're going to have 2 sine of x plus 2x cosine of x minus 2 sine x. And what happens is these two terms cancel out. So we're left with 2x cosine of x. Now this one is rather difficult because here we've got 3. And people would say, well, power rule only works when you have 2 factors. Actually, no. It does work when you have 3. What we have to do is we have to treat 2 of these as a single function. So we're going to treat this as one thing, and we're going to treat this as the other. Now, power rule would say, well, we take the derivative of this, leave this alone. Then leave this alone, and take the derivative of that. But this itself also has power rule, so we're actually going to end up doing power rule twice. So let's do that. So f prime of x is going to equal, now we need the derivative of this. Well, the derivative of that is going to involve power rule, so let's look at this. The derivative of the first part is 2, and then we leave the second one alone, x minus 5, and then to that we add first part, the first factor, 2x plus 1 times 1. Now again, this is all the derivative of the first part, but we're still taking the derivative of the whole thing. Power rule says take the derivative of the first times the second. We did the derivative of the first. That's this whole quantity. So let me just put an extra bracket around everything. Times x squared minus 4. We left that alone. Now we're going to add to that 2x plus 1 times x minus 5. That's this function that we left alone, times the derivative of this. And this derivative is 2x. So let's simplify this. Inside here we have 2x minus 10 plus 2x plus 1 times x squared minus 4 plus, what I'm going to do is I'm going to expand these two out. So we have 2x squared minus 10x plus x minus 5 times 2x. Now let's simplify these and combine our like terms for both this one and for this one. So we have 4x minus 9 times x squared minus 4 plus 2x squared minus 9x minus 5 times 2x. So now we'll expand these two. So 4x times x squared is 4x cubed. 4x times negative 4 is negative 16x. Negative 9 times x squared is negative 9x squared. And negative 9 times negative 4 is positive 36. Now I have to multiply each one of these by 2x. So 4x cubed minus 18x squared minus, not 5, 10x. So now let's combine like terms. Start with the highest power, x cubed. So we have 4 and 4. So that makes 8x cubed. Next we have x squareds. So we have negative 9, negative 18. So that's negative 27x squared. Then we have x, negative 16, negative 10. So that's negative 26x. And then finally a constant, we only have 36. Now this is an example where it is a polynomial, but some people may choose to just do power rule instead of having to expand it out. And you can do power rule when there are 3 factors. But some of you may just prefer to expand it algebraically first before you find the derivative using power rule. And it's more up to taste. It's up to you. So for the last one, what we're doing is let's just generalize the pattern that we've been using. So here we have 2 generic functions, g of x and h of x. So to find the derivative f prime, we're going to first find the derivative of g of x, which is g prime. And we're going to multiply that by h of x. We're going to leave it alone. And then onto that, we're going to add g of x and then multiply h prime of x. And this right here is the textbook definition of power rule. This is what you will see in all of your textbooks if you're studying calculus with a textbook, is you will see this as the definition. And so you can plug in any two functions in for g and h of x, and this rule will always work. If you like this video, please give a thumbs up. For more videos, click the subscribe button. If you have any suggestions or problems you want to see worked out, type in a comment below. And if you want to support the channel, please click the Patreon link to keep this going. Thanks so much for watching, and remember, the only way to understand something is to do it.